All right, what's up, people? I hope you're doing good. Can you hear me in the chat? I want to look at the chat now. Can we have some noise in the chat, please? People, what's up? We are here on the day 3, and the specific thing about today is that you're not gonna see me probably till end of the episode, till end of the session. I'll be behind the scenes. You'll be only listening to me. Acha, people want music. Okay, let's play some music also, but in the low volume so that you can also parallelly hear me. Perfect. So you can't see me today, that's what I was telling, and lots of things. Grab some water, grab a cup of coffee, tea, or water should be the best.
आप अभी भी यही हो? आप ना
अरे
ऐसे
यार,
गानों के असली फैन हो ही नहीं सकते। No
Spotify
chance. क्योंकि
advertisements, that's it. Anyways, podcast in YouTube. Yeah, no, this is not gonna be podcast, but that's a good idea. Sometime I'll also try that. Tomato soup best. Yeah, tomato soup is the best. Awesome. So shall we start? So a lot of things today. Okay, and guys, excuse me for apologizes for starting in almost 10 minutes late. And lot of things were happening this week, and we were not able to, I was not able to make the slides. I was not able to prep anything. But I have things for you, don't worry. We will learn a lot. We'll actually do most of the things on this episode. This is the most important session for today. If people are missing out this one, then I don't know, you're missing out on a lot of things. Okay, so without further ado, let's start, because we lot of things to cover and we don't have much time. Okay, shall we get started? Can I see some messages bombarding in the chat? 19 people here. Can all 19 people message 19 times in the chat so that it will make some noise? All right, also hit that like button. I'm already, never mind. I'm not used to these things, so it doesn't matter. But yes, it helps the YouTube algorithm, so that it helps other people to get to know that something super crazy is happening here, and they'll come here and they'll get to know about these things. Yep. Discord pay? No, yeah, I don't want to now open Discord and all these things. Already a lot of things to handle on my PC now. But anyways, if you want to listen to music after this session, you can listen to music, or we will play few music at the end. Okay, we'll play some music at the end. All right,
रियल फैंस तो
shall we
बिल्कुल हो
get
जाते हैं।
started?
मजा
Shall
ले
we
जो
get
मुझे ऐसे
started?
interrupt करने
I'm
से।
not seeing the excitement in the chat.
इसीलिए तो
I'm not
Spotify
seeing the
Premium पे
excitement in
shift
the
हो जाते
chat.
हैं।
I want
हाँ, वो भी है कि वहाँ
excitement,
अपने दोस्तों के साथ ग्रुप सेशंस पर सब एक साथ सुन भी सकते हैं। अरे
because
आपका गाना शुरू होने
I am
वाला है।
feeling
चलिए बाय।
little low
अब तो
today.
शायद आप भी Spotify Premium
Not
ले लेंगे,
on
तो मुलाकात हो ना हो।
low on energy levels, not on psychological levels, because I'm good at handling myself.
ओहो, क्या आवाज है मेरी, नहीं आर्टिस्ट की। ऑब्वियसली मेरी आवाज सुनता ही कौन है आजकल, आपको छोड़ के। अब तो कितनों ने Spotify
You might be
ले लिया
hearing
है।
some ads then.
वैसे ठीक ही है,
Possible.
अब बस म्यूजिक के बीच एड्स कौन सुने, और जब ये सारे गाने बिना नेटवर्क के ऑफलाइन भी सुनने को मिले तो मुझे क्यों सुने
You might
कोई?
be hearing some
मतलब कोई
ads.
और, आप
I
सुनिए,
can't help it.
मॉडर्न बॉलीवुड
You want some music? Take it. was waiting for people to hit at least 20. Now let's get started. Okay, a lot of things to cover today, and let's not waste the time. Okay, so it's not copyright, these are copyright free musics that I play on your Spotify, that which are meant for streaming. Okay, so no issues with that too. Perfect. Chalo, let's start. All right, where do I start? So BelkIoT Boot Camp day 3, and let's see, we have day 3 getting our, we are still getting our hands dirty on the perception layer, but we'll also touch upon the network layer today. Okay, remember, if we were talking about the 3-layer architecture, and for those who are joining in for the first time, please feel free to continue with the session and then go back and watch session 1 and session 2. That will help you to understand what we are exactly doing. So quickly to summarize what all we have been doing so far. In the first session we try to understand what is IoT, how to come up with ideas, how to break down the whole complexity of IoT into simple chunks, and come up how to brainstorm ideas, how to so also we did set up aim for what we want to do in say 5 in these 5 sessions. By the end of these 5 sessions, we laid a roadmap for ourselves. We actually placed our heart in the 5th day, and we are just trying to follow and reach our heart on the day 5, right? So we came up with idea. When we have idea, we also associate our heart with it, because that's our idea. We fall in love with our idea, and then so we did that. We placed our heart there, and we are now going to go, and we are one step at a time, we are going close towards our heart, and we will definitely do pretty amazing things, right? Awesome. So today is day 3, and in day 1 we did that, and day 2 also we looked at, we started with the hardware. We started understanding how things work. We started understand in this particular boot camp we are working on ESP32 module, which is one of the robust and powerful module that's out there currently in terms of microcontrollers. And yes, we try to understand how it works and all those things. And now in the session 3 we are going much deeper into that. We will try to understand different aspects of it, right? Chalo, so let's get started. We don't have any further slides, so let's stop it, and then we will switch to this view. Perfect. All right, so these are the topics that we are going to cover today. Okay, let me quickly actually resize this one. Yep, this looks a little better. Okay, because we will be looking majorly at the hardware today, right? So that's how it should be. Hope you are able to see the hardware today a little better. Last time it was a little glitchy. Okay, so these are the things that we are going to cover. First, in the last session we left out with a couple of things. We'll cover them, and then we'll understand few more concepts how to do. We'll take up our assignment, and then we'll hop onto the network layer, and we'll close it. That's it. Pretty straightforward, right? Boom. What is it? Boom. Okay, So here are the things. So let's start with the hall sensor. Hall sensor, for those who do not know, hall sensor is I will today use paint, okay, to draw things. I will also use incognito mode. Oops, not incognito mode. To access few websites. All right, before we go there, let's go to the paint. Okay, so hall sensor, what is hall sensor? Okay, hall sensor basically measures magnetic field. Okay, anyways, I'm not this is the best thing I love. This is the best application I love. A lot of people say Notion is good one, but I am in love with OneNote. I always use OneNote. All right, let me also bring the chat up so that I can keep looking at the chat. Perfect. Okay, so we are gonna look at hall sensor. Okay, let me increase the size. Where do we increase the size here? Visible? Not visible. 28 is visible. It should be visible. Fine. So hall sensor. Okay. So how does what is a hall sensor, right? So hall sensor is a sensor which monitors the magnetic field around that sensor. Okay, so we are gonna look at how that works and all those things, right? And guys, a good disclaimer before we start today. Okay, one thing for sure is you don't try it while I am showing it. Okay, today, just to save the time, I have already written down all the codes. I have saved them for you. We will not write the codes from scratch, but we will rather go through the code one line by line. I'll try to explain everything, and also I'll try and explain things how they are, just to save time, because last time we went over 2 hours, and I don't want that to happen today. Let's quickly close it today, and but still we will cover a lot of things. That's how I planned it. So every demo that I show, after that I'll give you 5 to 10 minutes to do that. Okay, in that 5 to 10 minutes is when you have to try it. Okay, you can start looking at it. I will you can, or while I'm connecting, you can also pull your hardware and connect it, but don't write the code while I am writing it. Hope you get it, right? Because it would lead to confusion, so you might miss out on some important points, and I don't want that to happen. Okay, clear? Make sense? Oh, give me one quick minute, and okay, perfect. Okay, so let's start with the hall sensor, right? So what hall sensor is, as I told you, is a magnetic it detects the magnetic field. I would suggest you go back and watch a video from I guess the YouTube channel name is Learn Engineering or something like that. They have pretty well showed how to, basically how this magnetic field works. So basically, just to explain, let's go to this website. What is that website? I forgot the name. Every circuit. So every circuit is a good website, guys. So you can also use this website. This is pretty cool website. The best part about it is, it also has a mobile app. Most of things are free of cost in this. Why is it not working? Okay, fine. So once you come to this website, you just have to click on open and available on Chrome. So just click on this one. So you can basically create circuits here, basic circuits, and you can simulate things. Okay, we will be using this particular thing a couple of times today, because a lot of things are there and that we can use here. Okay, so how does, gosh, why is it taking so long? Yep. So how does a Hall sensor work? Okay, so assume you have a metal plate, any small metal plate. Okay, arey yaar. So this kind of any kind of circuits you can build here. Let me, where is a new circuit? So let's assume we will not have a, I guess we don't have a metal plate here in the option. But anyways, so let's say you have a battery here, and you have, let's say this resistor, let's assume, okay, so this is a plate. Just assume that this is a plate. Okay, just any metal plate for that matter. Okay, just assume that this is a metal plate. When we pass voltage from this, voltage across this, so this is kind of battery, and this is a metal plate, and this metal plate, we are connecting it to this one, right? So pretty simple circuit, right? Now when I connect this, what happens is the current is passing just like this. Okay, the current is passing through this resistor, and then going back, the charge is being passed through that, and then it is that's how the circuit is built up, right? Now in this case, what happens is, if we have a metal plate here, okay, and we bring some magnetic field around it, okay, we hold a magnet and we bring a magnet to just nearby it, what it does is it let's say, this is a square magnet, something like this. Let me actually, let's use paint. So let's say, this is a magnetic field, and the electrons are passing like this from this, from one end to another end. I'm very bad at drawing, and upon that I am using a mouse to draw, which is hilarious. You got the point, right? So assume this is a battery, okay, and the electrons are passing like this. Now when you take a magnet, this is north, this is south pole, okay, and when you try to bring a magnet towards this, what happens is, suddenly these magnets, these electrons start deflecting to one side of the plate, this plate. So they were going in a straight line. Now what they do is they deflect, and they start okay, they were going in a straight line. Now what they do is they start deflecting like this. The electrons, okay, the negatively charged particles start taking this kind of path. Weird, right? So suddenly they start going around. They do circles around a temple, something like that. Okay, so they are going in a round fashion. So when they are deflected, all the negative charges go to one side of the plate. Automatically the positive charges, these are negative charges, okay, so all the positive charges come to one side, okay, and hence this plate also becomes a kind of this plate has, whenever there is difference between the positive and negative electrons, there is a voltage that is developed. Okay, there is a voltage that is developed between these between these on this plate there is some voltage that is developed. So if you take a voltmeter, and if you put one the negative leg of it and the positive leg of it on the other side, you'll start seeing some voltage. Okay, so it is starting to generate some voltage. This is a unique thing about it. Now that voltage is very minute, okay, but still it is giving some voltage, and that voltage is kind of given to a amplifier which amplifies the voltage and so on. So we get to know that there is some magnetic field. Okay, so if I bring a north pole, then the electrons might move on one side. If I bring a south pole, then they might move on the other side. Okay, so sometimes if we bring a north pole, we will see positive voltage. If we bring south pole, we will see negative voltage. Okay, so that's how we will see both positive voltage and negative voltage. So which brings us to the conclusion of how Hall sensor work. Like if we see a positive voltage, then we can understand that this is let's say this is north pole. It depends, man. I mean, it depends what kind of poles they have connected internally to that plate, but how they have connected it. But usually if they connect it properly, if we bring north pole, then we might see positive voltage. If they bring south pole, it might show some negative voltage. Okay, based on that we can detect that okay, there is some magnetic field that is that we can see around this plate. There is some magnet around this plate. Okay, so was that clear? Were you able to understand what I am trying to say in the chat? Hope. All right, okay, I hope you were able to understand. So where do we use these sensors? We use them anywhere where we let's say we have these oops so we have this ABS braking system, right? So do you know how this ABS braking system works? ABS, in all the vehicles and all these things, we have this ABS system, right? Which earlier we used to apply brakes to our vehicles quickly, just like that. But with ABS, we kind of changed it, and we were how it works now is, let's say the wheel is rotating fast, and we don't suddenly push the brushes, the brake pads onto it. We fastly switch the brake pad on it. We just touch it and then remove it, touch it and remove it, touch it and remove it. We do it at high frequency. So the brake is not applied abruptly, but even if you are in high speed, if you apply brake abruptly, what happens? If you're on a bike, you might start rolling the bike. Also you will be starting to roll with that bike, right? But if you apply ABS, what happens is it is kind of smoothening the process of applying a brake. Okay, so that's what ABS does. So how do we know yeah, Akshat says it prevents tires from skidding. Why does it prevent? See, whenever you quickly apply a brake, when you quickly apply a brake, it it completely has a lot of resistance, and if you've ever gone through the concepts of rolling resistance and all these things, I don't want to go into depth of this subject because we don't have time, but essentially it's like it's breaking your wheel step by step, not at once but in step by step. Okay, so when that happens, your bike wouldn't skid, you will not roll, or your bike will not lift into the air, or all these things would happen. So to apply this braking, we should know, right, how much with how much speed should we switch these brake pads. To know this speed is where we will use this sensor, Hall effect sensor, which looks at the wheel, which looks at the wheel, how it is going, with what speed it is going, and then based on that the application is the brake is applied. Okay, so this Hall sensor is basically used in any vehicle to detect the speed of the wheel. Okay, how does that happen? How does that work exactly? Go and check videos on YouTube. There are a lot of videos. I can't go into the depth unless I have some good animation or something like that. Okay, and I don't have anything for that matter as of now. I hope you understood the concept behind it. Okay, so now that we know what Hall sensor does, we will try to work on it. Okay, so let me quickly grab the code. Day 3 we have I was actually trying something else also, but that didn't work anyways. Hall sensor. Whoa. Okay, so this is the code, guys. Don't type the code, just try to understand. It's very simple code. Okay, what we are doing is the whole crux of this code is this Hall read. Okay, this is the method, this is the function which starts reading the values for us. Okay, so this is a bare minimum code which you will find anywhere on the internet. All right, so what we are doing here is, let's remove this because I haven't explained you how if works. All right, so here we have set the serial begin. By the way, first important point, I forgot to mention in the last session what is the serial begin. Okay, so serial is a serial monitor, I would say. Okay, you have this you have these, what do we call, these equipments, right? This ESP32s and all these things. So we don't know what is exactly happening inside, right? Because let's say if you are running a program on a laptop, you have a monitor where you can see directly what's happening. But to this, we can connect we can connect small screens to it. But to in the development phase, we wouldn't connect to the this thing, but rather we are connecting to our laptop. So we would look at what is happening inside on our screen, right? So we should get a place to monitor these values. That's what is exactly serial begin. Okay, so it opens up a serial monitor. So this is called serial monitor. If you click on this magnified glass kind of thing here, if you hover here, you see serial monitor on the top right. And when you hover here, when you click on this, you'll see a serial monitor. Whatever messages or anything that you put on this code would show up in this window for us. Okay, and what is this 9600? Okay, so 9600 is the frequency at which they are talking. Okay, let's understand it this way. All right, let's say I am talking, okay, I'm talking to you, and I've recorded a podcast, okay, I've recorded a podcast. You understand it only at a frequency. Let's say if I talk only 5 words, only 60 words in a minute, or maybe 100 words in a minute. Even if I talk 100 words in a minute, or 200 words in a minute, you'll be able to understand it. But let's say if I talk 1000 words within a minute, if I talk so fast, okay, I mean, basically I'll not be able to talk. But if I record it and then, you know, increase the tempo, and, you know, basically you'll hear it I'm talking very fastly, then will you be able to understand it? No, right? So your listening and my talking should be in the same frequency. All right, frequency that humans can understand, right? So that's exactly this 9600 is. We will tell our ESP32, and we'll also tell our system that you both should be talking on the frequency of, this is actually called baud rate, okay, on the baud rate of 9600. You will also see, if we have opened this, you know, close all these things, okay. Here you will also see this baud rate, right? So if I have to select 9600, we'll also try and change, we'll also try that, okay. Now let's this is the serial begin, right? So serial is the internal method that Arduino, you know, that comes in the inbuilt library, which talks on the serial channel, because this is we have connected it via USB, and it is having a serial connection with the computer. So there is a serial method which reads all the packets that are coming serially over that channel, over the COM3 channel, and it would you know, it would change it into human readable format, and it gives us. So we have to initialize that thing. We have to tell that, boss, get up and start looking at what is coming inside, okay. So the serial is kind of our radio, I would say, okay. If we have our radios, we have the signals all around the world, but our radio is what takes those signals. It would convert it into you know, human listenable format, and it plays that whatever is the message in that you know, in that signals. All right, so just an analogy, okay. So serial is that method. So we will stay turn on, okay, and turn on, and you tune in at 9600 93.5 red FM, okay, something like that. So this is 9600 is its frequency that we are setting, okay. So this is the best example, you know, understand it like a radio. A serial is our radio. We have started it, and we are asking, we have turned on the radio, and we have set the frequency to 93.5 red FM, and we are able to hear the 93.5 red FM. So we have set the frequency to 9600, right? Just a quick analogy. If you go deep into the subject, exactly it's not working that way, but you know, just analogy. All right. So next, going into, so this is the void setup. You understood it. So whatever setup, whatever turning on, you should do this, you should do this. This is the manager, you know, you understand it, this one like a manager. It tells everyone, you should do this, you should do this, you should do this. All right. And this is the slave, okay. This is like a operator or a slave or anyone, okay. Whatever manager defines tasks, loop does those tasks repeatedly. That's it, okay. Just understand it like that. All right. So initially we have defined a variable. Variable is just like a container which stores all the values inside it, okay. Not all the values. It would store, it would have its own life cycle and all these things, but you know, it would basically store the value that is being fed into that. It is just like a container, you would say. You know, if let's say you have a glass, in the glass you can put water, you can put wine, you can put anything. All right. So that's the thing. Next, So this is the important part. So like there is serial, there is also hall read. Hall read is a function which reads the sensor value. There is a sensor inside this and it is reading that sensor value. Okay, one quick second. All right. So it is reading the sensor values that are inside this. So this if you see this one, so our hall sensor is placed inside this part. Okay, so this is the ESP32 ROM chip and the hall sensor is inbuilt inside this. Okay, it is inbuilt inside this. Now this particular hall read is reading the values and it is then printing it is giving a message that hall sensor measurement is okay. So this exactly prints the values onto our serial monitor. So what are we doing? Serial dot print. So serial dot print prints the exact message as it is. Nothing, no brainer. Okay, whatever we write here, whenever it is executing, if it comes to this point, it exactly prints this line onto our serial monitor. No brainer in this, right? Just simple thing. Whatever we have written here, it would print that. Then it would go to hall value. All right, and whatever it has read the sensor value for using this method, right, and it stores it into this. So earlier we have defined its value temporarily as 0, but once we store that value into this, what are we doing? Hall val is equal to hall read. So what happens here is the value, the sensor value that it has read would be stored into the hall val. So like, this is, assume this one like a wine bottle, and you are assume this one like a wine factory, and it is producing the wine continuously. It is getting wine from somewhere, and then we are pouring that wine into this glass. Okay, and then this serial is again prints out the value for us. If you observe, there is slight difference in between these two things. Okay, here it is print and here it is print ln. What is the difference? Let's look at it. Okay, let's first upload the code. I've just used the shortcut Control U, and it is uploading the code to our ESP32. So it is compiling. Once it compiles, it will start uploading the code. Okay. For this particular thing, you don't have to do anything. You just have to connect. There is no hardware connection to this. You just have to connect your ESP32 to your laptop, and selecting the port and all these things as it is. Okay. What's wrong? It's uploading the code now. Okay. See, we started to see the measurement values. So what are these values? Let's try to understand. Before that, let's understand this print. Okay, here whenever we give print, okay, it will, whatever you write after this line, it would print it in the same line. Like here in the first iteration, what it did is it printed hall's sensor measurement is, it just printed that, and after that in the next line one also, the next line also, it printed it in the same line. Okay, this is one line. Okay, this is one line. All right, anyway, this is one line of code. Okay, and it printed it, the next value also it printed exactly in the same line. But for the second one, we have given print ln. What it does is it prints whatever is in this line, and then it moves the cursor to next line basically. You know, if like, assume you are typing it in a Word document, you have written it here, and after if there is println, it just means that you have typed enter and you're entering to the next line. That's it. Okay, now let's understand these values. Okay, every time it is giving some random values. I don't know why. Okay, the reason is, let me not go into that first. Let me show you some. Let me try. Actually, guys, I don't have a magnet as of now, but one jugaad that I can do is any DC motor. If you pick any DC motor, it would have some kind of magnets inside this. So this is a motor. Okay, so this is a motor. Any DC motor you pick up, there would be some kind of magnets that are there inside that. Okay, now I am placing this DC motor exactly here, and let's see if we get some change in the values. If we see any change in the values. No, right? I don't see any values. No drastic change in the values. It's still revolving in the same range. Why is that so? Because what's happening is it is working at a very high frequency, and here we have given 2000 delay. Okay, and what it means that, let's say there are 100 values being generated in 1 second. Okay, there are 100 values being generated in 1 second. In 2 seconds, which is 2000 milliseconds is 2 seconds. So out of 200 values, we are only picking one value, and we are showing that value here. Are you getting it? Are you getting the concept? Out of 200 values, we are picking only one value, and we are showing that value here. Okay, let's do something. Okay, let's remove the delay, or let's comment it. Okay, I told you last time, if you comment something, it means that it is not assuming it. By the way, here also we have commented it. That's why it is not executing this part. Okay, all right, let's upload the code again. All right, code is uploaded. Let's look at, oops. See, now look at the values. It's coming at a very rapid pace. All right. So there is no delay, and we will not be able to read it also. That's why we add delay, so that at least, out of 5 values, out of 1000 values that it is generating, we would be able to at least catch one value, and based on that one value, we should be able to read it. But in reality, what people do is, they would capture all these values. Okay, they would capture all these values that are coming within a second or within 2 seconds, and they would average it. Okay, so these are the advanced topics that we would go into later, in the later boot camps, or the advanced boot camps that we will be coming up soon with. We will be going into that, data processing. How do we process the data? How do we, clean the data, and all these concepts? We would be going into that later. But just understand that why are we adding this delay? Okay, there is a reason for adding this delay, and these values are very random. We don't know. And the fact is that the Hall sensor inside is of no use. I've read a lot of blogs on this part, and they pretty much everyone agreed that even on the ESP32's blogs, or the official communities, I've read a lot of people commenting that, and even few people commenting that actually the hall sensor inside is of no use, or it is not that sensitive that it catches every of the each of the values, right? So now if I place it, still no change. That's the reason. But before telling you that thing right away, I wanted to tell you how we look at the data. So that's so for this hall sensor, just go back with this one lesson of how we should interpret the data, how we should look at the data. Okay, so there is no point in I putting it any at how many yeah, now the see, oh, there was some change. Sometimes it works, sometimes it doesn't. Come on, we don't have the whole day. Anyways, people, if you have any permanent magnets, then try out with that. I hope you should be able to see some change in the value. Usually it revolves in the range of 2000 to 0 to 20, which are garbage values. I mean, not garbage values, but they are happening because of the the magnetic field that's by default available in the environment. So but if you bring a permanent magnet around it, with the magnets that you play around with, if you bring those magnets around this, then you will be able to see some kind of deflection. Okay, if you have a magnet, try using both the sides, the north pole and the south pole. Okay, try both try both the sides and see if you can get. But definitely let's upload this code with the delay, but definitely you will be seeing a difference in the value. All right, if you build if you have a permanent magnet, then try out with that, and you'll be able to see some substantial difference in the values. Like you'll be seeing values in 3 digits above 100 or something like that. Okay, so based on that, you can add some conditions, and then you can do whatever you wanna achieve. All right, so that's how we usually do. And if you try the other side, like if you are trying north pole, it is giving positive sides. Definitely if you try south pole, it should give negative values. I mean, for north pole, if it gave you positive values, for south pole it would give you negative values, right? All right, so that brings us to the end of this hall sensor. This is of no use. I read up a lot of blogs. You can also go and read about it, but that is of that was of no use, but we had it on our curriculum. So I just wanted to touch on that. At least we would get to know how to read the sensor values and all those things, right? All right, let's get to the next topic, which is touch sensor. All right, let's close this code. Acha, by the way, guys, you wanna I'll give you quick 5 minutes. All right, I'll give you quick 5 minutes. All right, so I'll give you quick 5 minutes. Go try this out. I'll open the code for you. Okay, you have 5 minutes time, and the code is also open here. Oh man, right, so you have 5 minutes. Quickly try it out, and then once the timer is over, let's start with the next one. me look at the chat and then. Yashwant says if I bring a magnet near ESP32, won't it affect its performance? No, no. Yeah, Rajesh gave the right answer because, however, these are DC circuits. In DC circuits, it doesn't matter about these things. Okay. All right. Oh, awesome. We have Techie SMS on the floor. We have Techie SMS Sachin in the chat. Thanks for being here, Sachin. It's a pleasure to have you. Guys, after, learning these basics, that's where you have to go for. Techie SMS is a channel. Go subscribe. No, I'm sure almost 90% of you might have already subscribed to him. He is the guy who has innate knowledge and has a lot of experience in this space. He has done a lot of projects. So once you get over with these basics, that's where you have to go. You have to learn things. Okay, Sanket says he got negative values. Sanket, try switching on the other side of the pole and see if you are getting positive values if you have a magnet. All right, we got 2 minutes more. Haha, Sachin, you got the best comment for today. You are the Sachin Tendulkar of IoT. All right, guys, hurry up. 1 more minute to go. 1 minute 30 seconds to go. People, if you are done, can you please drop done in the chat? If you have done it, can you please drop done in the chat? Perfect. Kajal is done. Akshat is done. Quick. Come on. Boom. Time over. Let's see. Perfect. Sanket has tried it, guys. On one side it is showing negative values and one side it is showing positive values. All right. So let's get to the next part. I will cover this part. I have commented this code, right? So don't worry about this. I'll cover how it works in the next part, because however the sensor is not working fine. So unless you have I mean, for me at least, I don't have a permanent magnet. I have something like this. Actually, I tried a lot since morning, but I couldn't find it. In my childhood days, we used to have a lot of magnets sticked under the metal tables. I couldn't find any of them. Anyways, Kajal says, why am I getting mostly negative values? See, maybe Kajal, your setup, the way you have put up somewhere around that place is where you have some negative. Sorry, I would say the either North Pole or South Pole dominantly, and those dominant values, that dominant field of that particular pole is is affecting that one. Okay, try I wanted to, anyways, let's not waste time here. We are already hour past. Let's make it quick, guys. I'll not go into the depth of the subjects or it will take ages to complete things. I'm sorry. All right, let's close it. What's the next thing? What's the next thing? So next thing is touch sensor. Okay, let's look at the touch sensor then. All right, so before we look at the touch sensor, let's quickly go and look at these things. What are these things? Let's look at ESP32 pin diagram. Are you able to see this? Okay, so hope you are able to see this diagram, right? So we have these pin diagrams. If you look at it, for few of the pins, it is mentioned as touch 9, touch 8, touch 7, touch 6, touch 5, touch 4, touch 3, touch 2, touch 0. Okay, so these are the 10 touch. I wouldn't call it sensor, but anyways, let's call it sensor. But these pins have act as a touch sensor. Okay, so it means that these pins, what are these pins? 21, 22, 24 and 20, 18, 17, 16 and 13 and 12. These are the only pins where you will be able to get the touch sensors. All right, what does that mean? It means that we have to connect our if we want to check those things, we have to connect it to these things only, right? So guys, again, in this pin diagram, it is slightly confusing. These internal pins are for this ESP32 chip, and these GPIO pins are the ones which you have to look at. So for touch 3, let's quickly use this side, which is, let's use 13. Okay, we'll use GPIO 13, which is touch 4. Okay, remember guys, this is very much important because GPIO is touch 4. So you'll always have to look at this pin diagram, which is very important, right? So we have GPIO 13 and touch 4. GPIO 13 is touch 4. Touch sensor. Let's open the code. while this boots up, guys, also quickly look at this particular thing. Let me maximize it up. Okay, so we have, what is it, D13, right? Let me move it a little close towards me, very far. So on this ESP32, from here, where on the right side you will have enable reset pin, right? From there, if you see next to VN, VIN, you have ground, and after that we have D13. So put your pin just next to it. Okay. I just have connected it. Pretty simple circuitry, nothing else to do in this. Right? So this is open. Now let's look at the code. Right? So again, the same thing, the manager part, and then the loop, the worker part. Here we have defined a variable, which is our container, which will store the values. Again, here it is touch read. But guys, what is the sensor value that we are using? It is D13, which was touch 4, right? It is touch 4. Okay, so I have to come here and have to make it T4. I want you guys, when you are trying it, you try out with different sensors. I have showed it with D13. You try it with different sensors. Open this ESP32 board anywhere, I mean pin diagram on your other tab, and just try it. Okay, simple one. It is reading it, and the same thing it is doing, it is printing it with a delay of 500 milliseconds. Let's quickly upload it and let's see what's happening. Is it taking so long? All right, done uploading. Now let's open the serial monitor. Okay, so we are seeing some values 65, 66, fluctuating between those values. Now if I touch it, look at the values. Considerable drop in the values, right? I've touched it. Oh, God knows. Okay, I've touched it, and there's a considerable drop in the values, right? Got it? So this is how touch sensor works. Now I just left it, and there is, again, it is going back to the same range. Okay, so see guys, understand this thing with sensors. It's always, there is slightly, if a lot of factors affect them, and the values are always jittery. I mean, you have to go by the range. Yeah, sensors always need calibration calibration means, balancing, kind of balancing them out, and accordingly using those values whatever we get. All right, so again it has gone back to that range, and if I touch it, it again goes back to boom, 0. Right, so this is how it works. Now before you try it out, I would like to show something else also. Guys, one fun fact: just try, whenever, if you are sitting on a chair, while you're touching it, try to raise your feet above the ground. I mean, don't touch your feet to the ground, and see what kind of values you are getting, and touch your feet to the ground and see what kind of values you are getting. I mean, again, they would be same, but you would see few values which are there is a sudden drop in the value, and again it would raise back. Okay, question yourself why that might be happening. Okay, it has something to do with what you do when you are building your new home. Okay, let me see, look at the chat if somebody was able to guess it. Anyways, yes, Akshat told it right. It is grounding. Okay, how many of you tried grounding, earthing? Exactly. We dig some hole, we put some salt and all these things, salt with some metal and wire around it, and we ground the whole circuitry, right? Why are we doing that? Because if there is any sudden fluctuation, it would drop the whole thing into that, because that is the that has the how do I put it, it is kind of shorting the whole thing, so the whole electrons would pass over there. Okay, so that is earthing. Read more about it. It's an interesting concept, what happens inside earthing. When we do earthing, what happens about it? Read more about it. It's an interesting thing to know. Okay, all right, so we will quickly do one more thing, and then you can give it a try. Okay, so now we have let me open this up. Yep, so now we have this one, right? So we have we are getting these values. Let's not print these values for now, and or let's print these values also, and then we go here and we write something called as if statement. Okay, if you are from I mean, if you are a coder, if you are a programmer, you would basically know what this is. But if you don't know, if is like a condition. Okay, you ask your mom, right? If I come with you to that marriage, then you will buy me a new dress. Okay, your mom forces you that you are coming with me to that marriage, and I usually don't like to go to the marriages or any functions with those people. If you don't know those people, right? And then you will put up a condition to your mom. If you promise that you will give me this thing, then I'll come to you, come to that marriage with you. Okay, so that's exactly that we are trying to do here. Okay, what are we doing? If touch, excuse me guys, no, it's not corona, no. Okay, if the touch value is less than 40, because if you look at these things, we are roughly getting the values around that. It's somewhere sometimes dropping to 40 also, so we'll consider 40 as a threshold. If the value is below 40, then we would consider it as that there is some there is the touch is detected. Okay, someone has touched it. So if value is less than 40, then we will print serial dot println of don't touch me, it will shout. Okay, if someone touches it, it will shout, don't touch me. Okay, let's see if it will scold me properly or not. Okay, so that's it. You just have to add that condition, and so whatever you write inside this, these square brackets, you have opened a square curly brace here, and you have closed this curly brace here, right? So whatever you write inside this curly brace, it will execute only if this condition is true. If the touch value is less than 40, only then it will go inside this curly brace, and whatever you write here, you write 1000 lines of codes here, it will only execute it if this condition that is here, touch is equal to 40, is true. Okay, if it is true. Okay, let's understand it. Now let's say the value, it has started the loop, touch is 0, and then it makes it reads the value. The touch is, I haven't touched it, the value is 60, and 60 is less than 40. Is it true? No, false. So it doesn't go inside, it skips it, it gives a 5-second delay, and again it starts printing the value. It starts from here, again it goes here, it sees 60, it sees if it checks if 60 is less than 40, no, then again it goes back straight. Now suddenly I touch it, what is this? It comes here, and then again the value is let's say 10 is less than 40. True or false? True. So let's go inside and then yell at him that don't touch me. Okay, don't touch me. So we have already uploaded the code. Let's look at the serial monitor. Okay, it's printing the value perfectly fine. See here, this is the issue. Suddenly there are some garbage values, and then it shows that thing. Okay, now I touch it, it is constantly scolding me, don't touch me. I leave it, it doesn't say anything. Now again I touch it, it starts scolding me, don't touch me. I leave it again, this is fine. Okay, interesting, awesome, right? So that's what we wanted to cover here. So that's another sensor for you guys. Okay, so let's also add some more logic here. Okay, let's connect one quick LED. Okay, how do I put the LED? And I connect one leg, which is negative leg, the cathode to ground, and let's use pin D27. Okay, use pin D27, and we have connected it to the positive leg. Okay, the leg which is lengthier. Okay, understood the circuitry? Pretty simple, right? One is this touch sensor, one is this wire which is open-ended where we will touch, and the other one, the ground has gone to the negative leg of the LED, the positive leg has gone to D27, right? Pretty simple. Right? Now let's quickly upload the code. Oh, sorry, we have to make changes to the code. Now here we have to write pin mode. See guys, always make sure that this color changes whenever the color changes. Change indicates that you have made it, you have given it right. 27 comma output. Okay guys, we are always giving output here, right? When will we give input? Any quick let me look at the chat. I'm looking at the chat. Let's see who answers first. When will we give input here? Guys, when I'm talking about something, exactly talk about that concept only. Okay, don't deviate and talk about yourself in the chat, because you'll miss out on some important thing and you'll not be able to do your assignments. Yes, Yashwant told it right. Whenever we have sensors, see, our LED, this LED is an actuator, which is giving out information. It is taking information from this digital world. This small piece of thing is inside itself, it is a digital world, and the outside world that I am looking at, that LED, it is giving me some light, right? It is outside the world, so it is giving some information to the physical world. So it is an actuator. Let's say this touch sensor, whenever I am touching it, that information is being fed into this digital world, right? So it is a sensor. So that for that we have to make it as input. Okay, now you might ask me, why didn't we give for T4, why didn't we give it as input? Okay, because this is an inbuilt sensor. All right, usually we define them if we are using GPIO ports. GPIO ports are these lines, these pins that we have for this board. Okay, for those we define them here. If they are internal sensors, we don't define them. Clear? Push button 2, yes. Push button is also, what is a push button? What is a push button, guys? Yes, it's a sensor, because it is taking some external thing inside it. Hai na? All right. Basically, see guys, understand the concept clearly. I've told you, like, whenever I've given you this hint, whenever you are using a sensor, it is input. Whenever you are using an actuator, it is output. But actually, we are not changing the sensor. We are changing these pins. The 27th pin, I am telling the 27th pin that, okay, 27th pin, you wake up and start taking values from outside. Okay, when it is a sensor. So if we define 27 comma input, I am telling 27th pin, you better start reading the values that are coming from outside. If I give 27 comma output, I am telling it that you better start giving out the values whichever I am giving it to you from inside. That's it. All right, so we have defined pin mode 27 comma output, and then we'll come here, we'll write digital write 27 comma high. All right, I'm sure you guys are experts at LED on off now. It will stay on for let's say 2 seconds. And then again digital write of 27 comma low. Okay, and yes, that's it. After going low, already we have a delay here, so we don't need a delay. Control U, which uploads the code. Okay, so whenever I touch it, it should be on for 2 seconds, and if I leave it, then again it should turn off. Okay, so the LED is not on. I touch it. Oops. Serial port failed to execute script. ESP tools does not exist or not connected. Ah, interesting. Done uploading. Perfect. See, Let's look at the serial monitor. Guys, by the way, did you understand why it was not able to upload the code? Serial monitor was open and it was already in some communication. While it is in communication, we cannot ask it to shut down and shut up and to upload other code. Okay, so we have to make sure that we have to close the serial monitor and then we upload the code. Okay, close the serial monitor just for being on the safe side. Reset the code, however that doesn't matter, and also and then upload the code. Even then, if it doesn't work, boot it up, put it in the boot mode. I mean, click on this boot and then upload the code. It should be fine. Let's touch it. Boom, it's on. Boom. So whenever I'm touching it, it's on for 2 seconds. Cool, right? Isn't it? Also here in the serial monitor, it is showing us that don't touch me. I touch it again, LED turns on. So that's how your imagination is the limit. With these devices, you can build anything. Now you can, whoa, this is the problem. I don't know. So what next? What next? Let's explain if else, and then we have applied the logic. Done. All these things are done, right? And then buzzer. Boom. Let's, all these days we were playing still just with this LED. Let's now switch. Instead of that LED, let's try buzzer. I don't know if you can hear it. Let me bring my mic a little close to it. Whenever I touch, it will start beeping. Boom, right? So that's the buzzer, but that's not all it. There's a lot more. We are already running out of time. Let's quickly do something else, right? So that's it, right? Guys, you understood it, right? So we had LED, we removed the LED and we changed the actuator. We changed the output information, the kind of information that we can show, or you can put both. Let's see. I'm not sure if this will work because the amount of current wouldn't be enough, but let's give it a try. Yeah, it's working. It's working. Perfect. It's working because I have a good grade of USB cable. This is a thick wire. If you use any low quality wire, then it wouldn't work because it wouldn't draw enough current from that. Lot of parameters which affect everything here. Okay. All right. Let's. I hope you understood it, guys. Do you want time for trying it out? Shut up. Do you want time, guys? Do you want to try it out? All right, take time. I will give you another 5 minutes now again. Okay, this one. I'll give you only 3 minutes because now you are experts. for 3 minutes. Start it. Go. Quickly try it out. Try out some things and then we'll switch to other things, right? Oh guys, it's taking a lot of time than I expect. See, that's why see, my problem is I always try to make sure that, you know, I go into the depth of the subject. But if we go into the depth of the subject, at least on online platforms, it wouldn't work because it takes a lot of time. I mean, we can't be live for a longer time, right? It doesn't look. But in the offline, we can go much into the subjects. We will have a board where we can draw and all these things. I don't even have a drawing pad. Anyways, but for the advanced session, it would be another level because it would be a closed environment. Guys, for those who do not know, we are also planning for a advanced session. Those who are interested, you can be a part of it later. You'll get to know the details about it soon. In the advanced session is where we will focus, and we are limiting only few students into it, few people into it, and it would be a very focused one where you will be you know, you'll be under our guidance, you'll be working with us, you'll be working on few projects. We'll learn every concept, we'll learn how industries work, we'll learn how, you know, everything. We'll do a lot of projects. You know, basically by the end of that advanced session, it will be a long period. Okay, so it would be roughly around for 5 to 6 months. It is a long-term plan, and that's how it would be. You know, we would be focusing on only limited amount of students, and we will be helping. Remaining people, you can be part of community later if you register for this boot camp, and then, you know, the same thing will open up later. But those who the criteria would be those who did this boot camp with us, and also in the further batches, would only be qualified for that. And yep, that's how it is. All right, done. Perfect. You guys are pretty fast. You guys are super fast. Awesome. Chalo, let's get on to the next one. The timer is not over yet, but still. So God, shut up. Okay, so what is the next one? PWM. Okay, guys, I wanted to go into the depth of this concept, but I'll skip it in the interest of time. But I will leave you with a resource where, you know, I thought I'll explain a little about it using, you know, making a circuit here, but we don't have enough time. But however, the best alternative would be to go to this website. Okay, I'll drop it in the chat. And guys, go and check this website. This is the super amazing website if you want to learn anything about you know, any concept or any IoT related things. Not IoT related things, but at least the embedded system part. Okay, toptechboy.com. This is where even I started learning. Okay, now this guy, the Paul McWhorter, who has been working on this, who is the instructor of that, has now, you know, updated the Arduino lessons also. The time I watched were the old lessons. Now he has also put up a new series of lesson in 2019, I guess. So I watched it in 2016 or 2015. So yeah, you watch, you know, you go and watch lesson 8 of on in this particular thing to understand how PWM works. You know, pulse width modulation. Let me quickly briefly explain you what is pulse width modulation, you know, because without that we can't go further. But let me also not waste much time here. Let me quickly explain you with a little concept, a little background, because that is very much important. Okay, guys. So this is your boom. No. Okay. Where is it? Wait a second, guys. I'm not able to find this option. No. Where is it? Uh, uh, this. Yes, there was an option here. There, here it is. No. Perfect. God, I missed this option completely. So yes, so I mean, this is a AC and this is a DC, guys. Okay, for those who don't understand circuits, this is alternating current and this is direct current. You remember I drawed it here on the paper and showed you in the last session. How does the alternating current, the current that you get in your home, and this direct current, what is the difference between that, guys? Actually, you know what, the quick fact here, this this direct current was introduced before alternating current, you know, and earlier there was nothing as called as alternating current. Okay, in all the at the time when Thomas Alva Edison invented the bulb, all the homes were supplied with direct current only, which was very dangerous actually, and all the bulbs that were made at that time were direct currented. But later Tesla came in and he changed everything, you know. Tesla is Bhagwan. He is literally God. I mean, the kind of inventions, the kind of thinking he had, he is huge. I just couldn't go ahead without mentioning him. So yes. All right. So, man, what's happening? All right. So high, I'll put it as 5 volts. No, not 5 volts. It will burst. Okay. And let's start the circuit. Oh, it's breaking up the circuit. Two volts. Okay. Rise also, let's make it 0. That's the problem here. We can't switch it. Anyways, understand, assume both these values are 0 0. Now, and look at it, guys. What's happening here. Okay, so it's switching from 0 to okay, this is a current diagram. Anyways, let's assume this is a current diagram, but we wanted voltage diagram. But anyways, both are same. I mean, not both are not same, but the diagram would be the same. Never mind. Yeah, so here we have 50% on and 50% off, right? So this is called duty cycle. All right, so in our digital circuits, if we want to fade something, right, like I told you, right, how our bulbs work. They fade from 0 to 100 and 100 to 0 and 0 to 100, 100 to 0. I know Sanket is saying, put some resistor. Okay, let's, don't mind. This is a simulator. So yeah, best practice is always there should be a resistor here or before the ground. Let's put it. Okay. Now it wouldn't work because we need more voltage. Okay, so you see it, right? So it is flickering very fast. Okay, by the way, Rajesh pointed it right. The duty cycle is the difference between the duty cycle is basically for how much time it was on. Okay, if I say it's 50% duty cycle, let's say can we pause it? If we, what's happening? Oh, again I switched it to this one. So the duty cycle is, guys, this one. What's happening? This is why I didn't want it to go into the subject now. It would show up all the weird things. Okay, it's now at least pretty step. All right, so look at this one. Don't worry about this fluctuations that are happening inside, but basically worry about the duty cycle. It's for 50% of the time, it's sorry, 40% of the time, because width is 40, it's on, and for remaining 60 seconds, in let's say the time is for 1 second, then yeah, let's say the time is for 1 second, then it is basically switching between 0 to 1. Okay, shouldn't have started it. It's taking up a lot of time anyways. Now we have the circuit back. Fine. So for 40 so if we take 10 seconds, for 4 seconds it is on, and 60 seconds 6 seconds it is off, right? So it is switching between those values. Now if I happen to reduce it, let's say to 10 seconds, for very short amount of time it is going on and off. Look at the LED also here. Okay, it is also going on and off, and also look at the LED here, which is switching so fast. Okay, so this is pulse width modulation, guys. Okay, what happens here is, in the digital circuits, we cannot always simulate the the analog values. So that is where we use pulse modulation. Let's say we want 2.5 volts. Okay, but it's defined 0 and 1, which is 0 is 0 volts, 5 is 5 volts. It cannot change itself, right, in the digital circuits. So what we do is we use pulse width modulation. Let's say it is on for 50% of the duty cycle. Okay, if we give the 50% duty cycle, then the average would come up to 2.5 volts. When we ask for, if we ask it to set to 2.5 volts, then it would switch, and it would average, it would do a PWM, and it would average to it would have 50% duty cycle, and then it would go have the average of 2.5 volts. That's how it creates the 2.5 volts. Okay, to understand this very well, go and look at this 8th lesson from Paul McWhorter, because in that he will use something called as oscilloscope, where you can in real time see the signals, what's happening. If he sets 2.5 volts, but I mean he sets 2.5 volts, but still it goes to it goes from 0 to 5 volts, but it switches because of the duty cycle. It changes the duty cycle internally, and that's how it does the magic. Okay, so in the real world, if you now want to blink a LED, okay, we have an LED here. Let's pull this off. Okay, so we have pulled it off, and then we'll quickly go and open up the code for fading. Did I miss out anything here? No, we didn't miss anything here, which is perfectly fine. And we have our, okay, this is the code. Let's quickly understand the code, right? Let me comment it. Here we will be trying out 2 different codes. Okay, so this is the second part, I'll show you later, but this is the first part. Okay, now here again, what is happening, by the way, is, guys, this is the best practice. Whenever you have a code, let's say in the earlier example, what we were doing is I closed it, I guess. So here I am see here 27, 27, 27. 3 places I have changed. I have given this same number, and let's say I wanted to change from 27 to let's say 25. I have to go and change it at 3 different places, right? So we want to make, let's say this this is a small code, so just changing at 3 points is fine for you. But let's say this is some 2000 lines of codes, and it is been this LED value is given at some 200 places. Would you be okay to go to 200 places and change it? Even if you are okay, what's the guarantee that you wouldn't do any mistake, right? So that's why the best practice is always to define the pin number here. Like here I'm going to use a buzzer, not buzzer actually, let's use the LED only, because buzzer you will not be able to clearly see it. So here I have assigned it for as a buzzer, and wherever I want it, let's say here we have used it only at one place, but let's say even if it is used at 1000 different places, I just have to change the pin number here, and it would be changed for all the places, because this is our container. Whatever is, we put it here, and wherever we use it, it is the same thing, right? So that's how it is. Now let's quickly understand how the fading works. If you want to fade the LED, you blinked the LED earlier. Now if you want to fade the LED, that's where we use something called as PWM. Here here we need 3 different parameters. Okay, one is frequency, at what frequency you wanna change the things, and we want to give the other one that we have is channel. Okay, and the third one is resolution. Okay, perfect. So this is the resolution for you guys. Now resolution is, if we are using 8-bit resolution or 16-bit resolution, that would be a little complex subject to understand, but basically understand it like this. Whatever value we give here would be, and how much value we are changing here would be 2 power 8 would be this value always. Just remember it like that. 2 raised to the 8 would be this value. 2 power 8 is 256, but we are starting from 0, so 0 to 255 is 256 values. That's how it is. So that is resolution, guys. Okay, so this ESP32 supports anywhere from 1-bit resolution to 16-bit resolution. So you can always also put 16 here, and then you can put, I guess the value is 32,556, something like that. Okay, I don't remember the exact value, but yeah, that you can switch from that values also. What exactly that means is you can change the values for those many times. Okay, I mean, let's say you are going from 0 to 1, you have a clock cycle like this. Okay, you have a clock cycle like this, 0 to 1. From 0 to 1, to go from 0 to 1, you have 5 volts, right? So these 5 volts, you can divide it into 256 times, and you can get those 256 times, which is 256 by 5 volts. Okay, so you can have 51.2 values. Getting it? So to go from just 0 to 1, you can switch between, you can have 51 different points, I would say. Hope you're getting it. No, actually it's not that way. See, understand it this way. Where is it? So 0 to 1 is 5 volts. Okay, so 0 volts and 5 volts. So we have resolution of 255, which means we can go from 0 to 256, which is we have 255 values, but if we have that 5 volts, which means you can actually logically divide it into those many times, right? Yeah, exactly. Now I get it. Sorry, I did it wrong. Mess it up sometimes. It's actually 256 by 5. Okay. Sorry. It's again, I did the same thing. 5 by 256. Which is, you know, this is the minimum resolution of this is the minimum resolution between one change to another change. Like here it is changing from 0 to 1 volt, 1 volt to 2 volt, 2 volt to 3 volt, right? So we can change from 0.019553.125, and then the next value would be double of this, and the third value would be again adding to that double, again adding the same value. So this is the minimum resolution that is possible. Okay, I hope I'm making sense to you guys. All right, so we can change values. The first, I mean, if we give 1 here, if we give 1, the voltage would be 0.01953.125. If I give 2, which would be into 2, which would be this value, and then which would be the third value would be this one. Oh, come on. Anyways, you understood that, guys. You understood it, right? So the third value would be 0.390625 plus 0.19, the initial value. That's the minimum resolution that is possible. Okay, so you can only change it by those many values. All right, so we have set it up again in the void setup. This is our manager, which we say, you know, we'll use channel 0, and then we'll use this frequency. Usually, you know, for LEDs it is always suggested to use 500 hertz, which is 5 kilohertz, and then resolution is we are using it 8. Now actually, guys, all this time we were directly assigning pin here, right? So if you observe, we also change the method here, which is, you know, for analog values we would use this LEDC write. Okay, so in the same way, here we have we have a channel that we defined, and that to that channel we assign the pin. Okay, it's like, you know, we create a route. Okay, we create a road which will be, you know, like in this road we will be only running 60 kilometers per hour, and then to that road we will put a vehicle which will run on 60 kilometers per hour, something like that. Okay, just an analogy. All right, so and then to that channel we have to make changes. Let's say tomorrow I am the municipal commissioner, and I can change that this will not be 60 but this will be 70. Okay, this will be 70 kilometer per hour. I can change the whole channel, and that channel, whatever pin is assigned to that channel would work on the same thing, on the same frequency. Okay, just understand it that way. Now here is a for loop. For those who do not understand, for loop is usually iterating few instructions with some defined condition. Okay, and in the for loop we will have 3 parameters. One is, you know, the basic one, which is where should the iteration start from. Okay, and what should be the condition to end the iteration. Okay, I'll come into it, and how often, how frequently should we change that. Okay, so this is the third one. Now here the literal meaning of this particular loop is, here duty cycle is 0, which means the iteration will start at 0, and then it will keep incrementing. Here duty cycle plus means for every iteration, once it goes, it will iterate, it will increase the value by 1. Okay, you can make it here plus means plus is equal to plus 1. Okay, or you can make it plus 10 or plus 100 or whatever. Okay, for now let's keep it plus plus. Okay, plus plus is equal to, I mean, plus plus, writing plus plus or duty cycle plus 1, both are same, right? So how it will work is, it will start from 0, and from 0 it will it will check if if 0 is less than or equal to 255, yes, then it will go inside, it will for the channel it will assign the duty cycle as 0, and then that LED will glow for with 0 volts, and then after, while leaving, then it will increment the value by 1, because we have written plus plus, so it will increase the value by 1. Also it will put a delay, and then it will increase the value by 1, and now the duty cycle value is 1. It will again check if duty cycle less than 255, yes, then it will come here. Okay, it will come here and it will assign 1 here. 1 here means, what is the voltage that is being passed to the LED? That voltage is the same value that we got here, this value. So it is assigning this value to that LED. Got it? So it is assigning that value to the LED, and then it is again going into the loop. Then again it assigns 2 here. Okay, if it so it keeps doing the same thing until it reaches 255. For 255 also it will allow, because 255 less than or equal to 255, yes, 255 is equal to 255, that's why it will allow it. Then if the value become 256, then it will not allow anything, and then it will directly exit to the second thing. And here now the duty cycle value is 255 right? Here we have defined the duty cycle value to 255, and now we are decreasing it by 111. Okay, so what we have done is, we made the LED glow. Okay, it became bright, and now it is fading back to 0. We'll look at it. Okay, same circuitry, we just have to connect it at which pin? 27. In my lucky number always I am selecting 27. I'll upload it, and now you'll start to see that LED is fading once the code gets uploaded. See guys, this LED will start fading now. So this is how it's fading. Okay, so it is always increasing by this amount of value, 0.1953125. But if we want to increase this value, how would we do that? We would go and increase the resolution here. Okay, let's say if we give 16 here, let's quickly look at that value. 2 raised 16 is 65,536. Now let's go again and do 5 by 65,000. What is the value? 536. So in if it is 2 power 6, then it means that this LED would be increasing with such low precision. Okay, such high precision, with such high resolution. Okay, so that's what would be happening in this case. Okay, now quickly let's do one more thing. Okay, in this we will quickly, this would be the last one to do. We will do the remaining things. We will again, as last time, we'll push it to the next thing. Guys, understand, please bear with me, because this is the first time we are not able to plan the timings, because these explanations need a lot, these things need a lot of explanation, and that's why I told you in the start, right? It might be 5 or it might be 6 sessions also. Okay, so please bear with me. I'll make sure that the concepts are not missed. I'll cover everything, but this might be extended to one more session, because we are always pushing out the concepts to next day and next day. Okay, so this is the one that would be left out. We will quickly look at the assignment that we want, and we will wrap up for today. That we want to do, and then we'll wrap up for today. Okay, so instead of LED, now if I put a buzzer here, I'm bringing it close to the mic. Not sure if you are able to hear it, but LED, now I changed it to the buzzer, and the buzzer is also fading. Okay, but in this code we want to do something else. We want to assign different values rather than fading it. We want to give it different set defined values. One is this one. Let's give something from 50. Okay, we are giving 255. It would beep for for at the full volume, and then at the high, at the half volume 50%, and also at 50, which is almost roughly 10%, if I'm not wrong. Not even 10%, yeah, roughly around that value. Okay, 10%, so it will decrease 100%, 50%, and 10%. Okay, so that's how the volume would reduce, and that's it. Again, it will go to 100%, 50%, 10%. The volume would decrease like that. Okay, guys, look at this one. This is very important for your assignment, right? If you hear it, we are only able to hear with only 2 sounds, because the third resolution, the 50, is almost not playing, because that voltage is not enough for that buzzer to make sound. Okay, for that buzzer to make sound, that voltage is not enough. So definitely try something between 100 or above values. Okay, then you'll find let's keep enough difference, make it 180, and then upload it. Okay, my battery is running low. See, now you will be able to hear 3 different sounds. Perfect. Now, this might sound a little funny, but that's how it is. Okay, so this is how we are playing with it. Now, the next final thing, which is our assignment. Whoa, I guess it switched. Okay, perfect. Take a quick look at the code. We have given 3 different values. One is 255, the next one is 180. Oh, sorry, I guess I missed all the values for you guys. Yeah, so 255 and then 180 and 100, because at 50 that voltage wasn't enough for that buzzer to make sound. Okay, at 50 it was not able to get that sound. So best practice is, now if you, when you are making your assignment, start using from 100, or what you can do is you can increase the resolution and find the exact number from where you can do that. Now you got how to you understood how to make the resolution. Make sure always, if you are giving 8 here, then the raise value 2 power 8 should be the value here, the highest value. Okay, let's say you give 16, the value should be 555, I guess, the same. That should be the value here. Okay, so that's how you play with it. Now the assignment, time for the assignment, quick assignment. Build a piano out of this. How would you do that? Build a piano. How would you do that? You have 10 different touch sensors, right? Only use 7 of them. Okay, 7 touch sensors, or let's make it simple. Just use 3 touch sensors. Okay, and use those 3 touch sensors as 1, 2, 3. And whenever you touch one, there should be one sound from the buzzer. Whenever you touch the second one, there would be a different sound from the buzzer. When you touch the third one, there would be a different sound from the buzzer. Interesting? So that's the assignment that you have to do. Clear, guys? In the chat, let me know if the assignment is clear for you guys. So that's the assignment that you have to do. You have to build a piano where when you touch the first one, it would make some noise. When you touch the second one, it would make the different tune. When you touch the third one, it would make a different sound. Now you have to combine 2 different explanations, 2 different examples that I gave today. One is the touch sensor, the other one is this one. Okay, fading. So you have to combine these 2 things and then work on your project. Then you'll be able to do this. That was a hint. That's it. All right, let me see if we have anything else. Yep, quote for the day. The real learning comes from applying what you have learned. Okay, so apply all things that you have learned. Come back and keep watching this video, and you make sure you try out everything that you are doing, or else it would be of no value, because that's how the learning happens. And also the most important point, guys, see, if you are expecting that you learn everything from here, no, it's definitely not. We are just laying the road to you guys. You want to trek Mount Everest, and we are teaching you how to trek a small rock. That's it. The journey will be yours. You have to go on internet, check everything, just Google up for anything. Now, by the way, this piano, if you Google up for piano, you wouldn't find it, because I don't give you. Last time, yes, traffic light, maybe you'll be able to find it, but piano, no, I don't think you'll be able to find it, because I usually pick up the assignments which are not available on internet. Yes, so, but still use the internet resources. There are a lot of people who have already made a lot of YouTube videos, everything for that matter, and they have done a lot of work. So why rework? Just why I should why I need to go through everything. I just tell you the route map on how you should learn things, and then you can learn things by yourself, right? So that's how we are planning this boot camp, at least the session 1. The advanced would be completely different, where you would completely learn the industrial things and all those stuff for that matter. Okay, right, that's the thing. And yep, I despite thinking that I'll complete it early, I took 2.5 hours for this session, which is okay, fine, right? All right, with that, complete your assignments again. This time maybe we'll have session on Wednesday again on the Discord server. And people who are not part of the community, don't worry, please follow us on our Instagram, and you'll be able to understand what we are trying to pull off. Okay. With that, do we have anything else? Yes, we have something, which is music. Let's listen to some music, and then yeah, that's pretty much it, guys. We will close it. And by the way, the next session is on 13th. Okay, boom. Please listen to the podcast that we are doing. Podcast has huge amount of value that you wouldn't find on YouTube, or you wouldn't find by reading any blogs, because we have industrial experts who are coming to our podcast, sharing what things happen inside the industry, what kind of job opportunities are there, how should you approach for a job, what kind of things are there in in every industry, how can you make a lot of money by getting into the IoT space. So keep listening to the podcast. You wouldn't find such knowledge anywhere on earth, is what I can guarantee. At least unless there are some industrial forums, you wouldn't find similar knowledge anywhere, at least on the open things out there. Okay, with that note, bye, thanks a lot, stay safe, take care, until 13th June. I'll see you next time. Bye.